Hello everyone. So we're coming back to the problem solving session of Physics 111. So in this program we are going to talk about the motion in the 1D under the influence of the gravity. So that's basically the free fall. So in this problem it said that a stone is thrown vertically upward from the edge of a top of a tall building. The stone reached its maximum height above the top of the building 1.6 seconds after being shot. Then after barely missing the edge of the building as it falls downward, the stone strikes the ground 6 seconds after it is launched. So basically if I draw that sketch of this problem, say that think about this is a tall building. From this tower of this tall building you throw that stone upward with a speed, then it moves to its reach to maximum height. After that is comes and barely miss that height and strike the ground. So 0.6 seconds later after being shot from the top of the tower. Now once you throw that stone into the air, it will move only under the influence of the gravity, right? So that's means only one force will be acting on that system or the stone. So that's how we can say that it's basically the free fall. And in this case we will neglect the air friction over here, which is basically the ideal case. Now fine, so they also say that it will reach its maximum height from the top of this building after being thrown 1.5 seconds later. So and the total time is 6 seconds to reach the ground. Now they asked me with what upward velocity the stone was thrown. Fine, so I can find out once is basically it's moving basically at a constant acceleration, which is acceleration is the z over here. Once you throw that one, when it reaches at the top of this trajectory, its final velocity would be the 0, right? That we can say that say Vy in that case would be V0 y plus Ayt, right? So I choose say this is my positive y direction and this is my positive x direction. So I just use that formula V equal to u plus at, but in that fashion. Fine. So this is the initial velocity is thrown towards the upward, and to find out this final velocity is 0 over there. If it is reached at top point, so definitely it's going to be that final velocity would be the 0. So then I can say, so this is the 0 V0 y. That's I want to find out. This is the initial velocity, it was thrown, minus 9.8. This minus basically g is acting downward. Whether you move to the upward or downward, g will be always downward direction. So that's why it's a minus sign, because I choose that upward direction is positive. And the t is take to reach at that point is 1.6 seconds. Then I can find out say V0 y would be basically 15.68 meter per second. So this is the answer of the question number 1. So that means at that velocity the stone was thrown. Fine. What maximum height above the top of the building is reached by this stone? So that means they are asking what is that distance from top of the building to this maximum height. Fine, I will use that one using the same formula. The displacement formula, y equal to y naught v naught yt plus half of a yt square. This is the only formula. If a system moves at a constant acceleration, we can use that general formula. Using that formula, basically we can find out 1D, 2D and 3D motion also. Fine. So if I choose that is my origin, then I can say this is actually the zero initial displacement. I'm going to find out this y, v naught y, I know that. Say this is 0 plus v naught y is 15.68, and it's take the time to reach that top point is 1.6 minus half into 9.8 into t is 1.6 square, right? So if I do that, then I'll find out that value of y would be 12.53 meter. So this is means the stone reached 12.53 meter from the top of that building. So this is the answer of that B. See how tall is the building. Now they are asking to what is the height of this building. Fine. That one I can also find out using that formula. Say y equal to y naught v naught yt plus half of a yt square. I'm going to use that one. Now say if I use that, I'll consider from here actually, or you can use starting from that point. Say if you choose this is the origin, right, then I can say the displacement of that one, that's I'm going to find out from here. So say I choose the origin again from there. So this is my origin. I'm considering the origin from there. Then this y naught is going to be the 0, right? This y naught again going to be the 0. Then I will find out this y. Y is 0 plus, now this time is take that 6 minutes, right? So, sorry, 6 seconds actually. So 15.68 into 6 minus half of 9.8 into 6 square, right? So because it's take the 6 seconds to come from here to at the bottom of the tower. Then you will find out this y would be negative 82.32 meter. So this is would be the height of this building. This negative sign actually indicating y. Basically, if you choose this is your origin, then you are traveling to the negative y direction. So that's how you find out that displacement is negative. You can say that the length or the tall of this building would be 82.32 meter. We can neglect that. In that case, the length of this building would be 82.32 meter. Fine. So this is the answer number C. The D, determine the velocity of the stone when it returns to the height from which it was thrown. So that's mean what would be that velocity when it is at the point over here, when it is thrown over from that height. So we can use that formula to find out, right? So velocity we can do is two way. Basically, you can use v equal to u plus ad, or you can use basically that formula, final velocity v square would be v naught y square plus 2ay into y. So this one would be basically the 0. I'm considering in terms of time. So then vy would be basically that plus minus v naught y. It can be the plus because it's moving to the downward. Then I'll find out this will be V naught Y, which will be minus 15.68 meter per second, right? So this is the velocity, because that's true, because we are neglecting that air friction. Whatever the velocity it was thrown, it will be exactly the same when it is come towards that point, but now this time the direction will be the downward, so that's why it's a negative over here. Fine. What about the E? E is asking find the velocity and the position of the stone at t equal to 5 seconds. So what would be that velocity? So velocity we can use Vy equal to V naught Y plus Ayt, right? I know that V naught Y, which is 15.68, initial vertical component of the velocity, minus 9.8 into 5. Then this will give you basically that minus 33.32 meter per second. Definitely it will be minus, because in that case it will be towards the downward direction. What about that position? Position I can also find out using Y naught V naught Yt plus half of a Yt square. This will be basically Y naught. Again I am considering this is 0. So 0 plus 15.68 into 5, because I want to find out the displacement equal to 5 seconds, minus half of 9.8 into 5 square. In that case, you will find out that the Y would be minus 44.1 meter, right? Which in that case it would be, at the time, is basically at half of this, at the middle, closely, because the height of the building is 82 meter. At the 5th second it would be 44.1 meter. This just cross the middle height of that building or the tower. So that would be that answer of this question number A. Okay, thank you very much.